So tell me if this has ever happened to you. A user contacts support because they're randomly seeing different order histories every time that they log in. Sometimes they see their recent purchases, sometimes they see orders from years ago, and sometimes they see nothing at all. After several hours of debugging, you discover that they have 3 different accounts with the same email address. Each time they log in, your authentication system randomly picks one of the 3 accounts, so they get these weird results. This nightmare scenario happens more often than you'd think, and is entirely preventable with proper database constraints. Hello, developers, and welcome to the PHP Architect channel. I'm Scott Keck-Warren, and today we're tackling a database design problem that causes real headaches, preventing duplicate database entries using unique constraints. If you're new here, we cover topics related to the PHP ecosystem, including relational databases, and hit subscribe so you don't miss our newest videos as they come out. So let's look at how this happens. You have a simple user table and a registration code that inserts the user's email and password into the database. And this works fine, but what happens if someone fills out the registration form twice? It's really common for people to double-click a submit button in forms all the time. Now you have 2 accounts with the same email address. When Alice attempts to log in, your query is set up to return the first result and not necessarily the correct one. Now, the question is, which Alice does the database return? And with a lot of technology-related topics, the answer is it depends. In this case, it depends on the query optimizer's mood that day, because without an explicit order by statement, we don't truly know what the first result will be. This inconsistency causes all sorts of problems like mismatched order histories or lost save preferences, and always results in confused customer support requests. Thankfully, relational databases have been able to handle this by allowing us to define a unique constraint on a column or group of columns so we can't add duplicate values. This is done by using the alter table or create unique index commands. For the alter table command, we use the following structure. We use alter table, the name of the table, add unique index, the name of the index, and then a comma-separated list of the columns that we're adding the index to. We can add a unique constraint to the email column in our users table using the statement that's on the screen. And now when we try to double register our user using the same email address, we get a constraint violation. Problem solved. Now you have logic in your application that will prevent duplicate email addresses from existing in the users table. But what if you need to be able to support the user deactivating or deleting their accounts, but still allow them to sign back up later? For example, your finance team doesn't want to completely delete their information because they might still need to process a return. To fix this, you can use soft deletions. When you soft delete data, you flag it as deleted or inactive using a deleted at or is active column to track the old user entries. In this example, use the deleted at column, where a deleted at column with a null value indicates the user is active, and a deleted at column with a value indicates the user has been deleted. So when your user deletes their account, we run something like the following. With this setup, all of the original data still exists in the database with the deleted at set, and we're able to retain all of the user's transactions for financial reports or returns or whatever we need to do. Now imagine that same user wants to come back and creates a new account. Because we created a unique constraint, it's going to block them because the old soft deleted record still has that email. Your user is stuck, unable to re-register with their own email address, which is going to cause problems because they're going to generate a support ticket and they might just give up and go use your competitor. We'll have a solution to this after this word from our partners. As a programmer, you know that code reviews are critical, but are also time-consuming. CodeRabbit acts as your AI co-pilot, providing instant code review comments and potential impacts of every pull request. Beyond just flagging issues, CodeRabbit provides one-click fix solutions and lets you define custom code quality rules using AST grep patterns, catching subtle issues that traditional static analysis tools might miss. CodeRabbit reviews 1 million pull requests every week across 3 million repositories and is used by 100,000 open source projects. CodeRabbit is free for all open source project repos. Get started today at phpa.me/CodeRabbit. That's phpa.me/CodeRabbit. Postgres provides an elegant solution to this problem with partial indexes. You can add a where clause directly to your index definition when you create it. This index only includes rows where deleted at is null, so soft deleted users are completely excluded from the unique constraint. The syntax is very clean, and the intent is immediately clear to anyone reading the schema. So unfortunately, other database engines like MySQL don't support partial indexes directly, but we can achieve the same result using what's called a generated table. A generated table is a column that you don't enter, but instead the database engine generates that data for us. We'll do it using an alter table like what's on the screen. But now we have to create the unique index using both the email and not archive columns. Now, this is a really cool trick, but it's a little obtuse. So here's how it works. The generated column not archive evaluates to 1 when deleted at is null, meaning that the user is active, and it evaluates to null when the user has been soft deleted. Your unique constraint works here because MySQL will allow multiple null values in a unique index. So when you soft delete a user, their not archive column becomes null and the unique constraint ignores them. Active users will have a not archived equals 1, so the constraint prevents duplicate active accounts with the same email address. And then deleted users have archived, not archived equal to null, so they don't conflict with any of the other rows. Pretty cool. Many software as a service applications need uniqueness within a tenant rather than globally, because each company using your platform should have unique user emails, but the same email can exist across multiple tenants. To do this, we will just add the tenant ID to our unique constraint. Now, Alice can still exist as an active user in both tenant A and tenant B, but not have duplicate accounts within the same tenant. As a brief recap, unique constraints allow you to prevent duplicate data in a database table. Simple unique constraints break when combined with soft deletion. MySQL requires a generated table that becomes null for deleting records, allowing the unique constraint to ignore them. Postgres partial indexes are cleaner, letting you add a where clause directly to the unique constraint. I hope this look into unique constraints will help you prevent duplicate data bugs in your applications. Now, here's my question to you. Have you had to debug a problem caused by duplicate data that should have been unique? I'd love to hear your war stories in the comments. Those real-world experiences help me create better content for this channel. If this video helps you understand a tricky database design problem, make sure you subscribe and share it with your teammates who might need to see this as well. It generally helps others find the channel. This is Scott Keck Warren for the PHP Architect channel signing off and reminding you to keep watching, keep coding, and keep reading.